Welcome to HexaShield.
A rocket launch is one of the harshest environments ever engineered by mankind. The thrust unleashed exceeds 4 million newtons, the superheated exhaust plume strikes nearly 10 times the speed of sound, and initial acoustic loads shatter 180 decibels. Hence, conventional pads are flooded with thousands of gallons of water in seconds to mitigate damage to the launch pad and the rocket. In fact, the water used by NASA's water dilute system in one launch is approximately equal to the water used by an average American over 7 years. Despite this, pads still require long and expensive maintenance cycles, driving downtime and limiting launch cadence, making ground infrastructure a growing bottleneck for developments in major spaceflight programs.
That's why we present HexaShield by Helion Solutions, redefining launchpad infrastructure with an 8-layer model tile system. The top sacrificial ceramic hot base absorbs exhaust, and beneath it, a high-temperature ceramic composite can bridge microcracks that may formulate thermal gradients. The acoustic suppression layer consists of an array of Helmholtz resonators that dissipate the most damaging low-frequency waves and refers to its kind of localized water cavity beneath the concrete, reducing peak temperatures without continuous water flow.
Close competitors include custom pad contractors with extensive maintenance cycles, in-house manufacturers whose solutions are not sold externally, and material suppliers which do not provide integrated systems. Hence, HexaShield stands alone in providing standardized launch pads that unify the above solutions.
We're the first launchpad to employ a modular system to localize damage, use sensors to optimize water distribution and flow rates within water cavities, and integrate a machine learning model for predictive maintenance. A post-launch maintenance cycle helps us to reduce downtime for firms, increasing launch cadence. During a rocket launch, various sensors log real-time data which is fed into our ML model post-launch. This proactively detects stress and hotspots before they compound. We then identify cracks at the layer level and replace only the damaged tiles, instead of rebuilding the whole pad.
Our system is scalable across rocket classes. Its cost reduction of 50 to 55% lowers barriers to entry for smaller firms in a high capex, certification-driven market dominated by vertically integrated firms. We compared HexaShield to major SME launch complexes like Firefly Aerospace's SLC-2W complex, where we would reduce annual launchpad costs by 60%. Even for larger launch complexes, we significantly reduce upfront as well as maintenance costs.
We validated our design by conducting transient thermal simulations under Rocket Lab Neutron's launch curves. Our core layer operates around 700 degrees Celsius below its operating limit, reducing damage risk, while conventional concrete-based layers operate only 100 degrees Celsius below their margin. Our modeling based on simulation results and acoustic damping requirements also revealed a 20% reduction in water usage for medium lift launches.
According to Moderate Intelligence, the reusable launch vehicle market is valued at $7.3 billion in 2026 and is projected to reach $9.8 billion by 2031 at a 6.04% CAGR, with orbital launches rising by 123% in the last 5 years. Cutting downtime and costs, an estimated 40% adoption gives us a $2.9 billion SAM. By 2030, we plan to capture $38.6 million of the SAM, serving university test centers and SMEs simultaneously.
Our cost of goods sold consists of a variable cost per tile of 69.8K for a range of 60 to 80 tiles. Fixed costs comprise annual operating expenditure of 12.6K and setup costs, amortized over 5 years of 3.4K per year, for a total of 85.8K per tile in the first year of production. Pricing is set for early penetration, followed by margin expansion as volume scale. Prices vary with a gross margin of 13.6% for early adopters and 27.6% for steady-state commercial buyers. This translates to mean launchpad prices of 5.9 and 9.5 million respectively. With an initial adoption of 15% of universities and rocket propulsion labs and a further 10% adoption in the subsequent year, we project to earn $162 million by 2034.
Over the past few months, we have created detailed CAD models, run simulations, and consulted industry experts. Over the next year, we plan to build and validate our prototype at labs such as those at IIT Kanpur.
We follow a market sequencing strategy, entering through a beachhead of universities and test centers and subsidizing pilot tiles in exchange for study data. We then establish a regional assembly hub, selling launchpads to SMEs and scaling to full sales.
Stage 1 raises 70K from grants and angels to validate HexaShield's core risks. Stage 2A secures 1.6 million from deep tech investors and grants to establish our first assembly hub. Stage 2B adds 800K through grants and pilot prepayments to install university test centers and reach full operational capability for our initial hub.
Hi, my name is Brennan, and I've been impressed by HexaShield's advanced modular tile system. It's my hope that through advising them with some structural design considerations and business model considerations, they would be able to take this project further and see clear business potential.
I'm Sanath. I'm Manirat.
I'm Siddharth.
And I'm Neil.
Join us to redefine launch infrastructure.